My name is Samson Hill, and this is my brother Crocodile. And today we are visiting the Radford University Planetarium.
The closer we get to June 21st, the summer solstice, the higher the sun's going to get in the sky, until it hits a point about right here, where it'll then start sinking lower until winter. Now, because the sun is really bright, it blocks out our planets during the day. Over here we have Mercury, Mars, and Venus. In a little bit we'll have Jupiter. Right now, there he is rising. You can see Mercury if you go out right before the sun rises, but otherwise it's going to get drowned out. All these other ones you can see right after sunset.
The search for life in the universe is ancient, part of our human nature.
Our search for life in the universe begins with the sun's orbiting planets. We will explore these alien worlds looking for life, past life, and for clues about why Earth is the most habitable planet in the solar system. Planets and moons of all sizes orbit the sun, yet only one has intelligent life, or perhaps any life at all. Why have these other worlds failed to foster life? What can they tell us about conditions for life to flourish?
The robot lander Huygens dropped through Titan's thick smog of nitrogen, methane, and ammonia to reveal the surface below. Titan has the atmosphere and chemical composition needed for life, but lacks an energy source to fuel its birth.
Solar energy increases as we move toward Jupiter, a planet so large it produces its own energy as it continues to shrink. Even with this energy source, life is most unlikely in Jupiter's violent, toxic atmosphere. But Jupiter's large moons could harbor life. Io is an amazing world of dramatic change. Erupting volcanoes, blasting material hundreds of kilometers into space, constantly resurface the moon. On Io, change is too violent and destructive, and the surface is too unstable for life to develop. Jupiter's moon Europa. Any life that might be swimming below this icy surface would be simple and primitive. On Europa, the necessary conditions are present, and there is a slim chance that life has developed below the ice. The scarred surface of Ganymede tells the story of impact on a vast scale. Ganymede has large cracks and linear scars that may be evidence for a slushy ocean trapped beneath, and another place to search for primitive life. Callisto, outermost of Jupiter's 4 largest moons, possesses the most ancient surface.
In 1994, a fractured comet plunged into Jupiter, releasing the energy of 1,000 atomic bombs. Any one of these comet fragments would have caused major damage on Earth, but Jupiter's gravity captured them, thus protecting the inner solar system. Development of life may require a giant planet like Jupiter in the outer solar system to protect inner planets from life-threatening impacts.
The red planet Mars is at the outer edge of the sun's habitable zone, the region where water can exist as a liquid. Ancient dried-up riverbeds indicate that long ago, Mars was much wetter. with an atmosphere thick enough to support water as a liquid on its surface. Life might have developed here then, but today's dry and cold Mars cannot support the emergence of life.
Called Earth's sister world, but a closer look reveals a nightmarish planet of intense pressures, extreme temperatures, and sulfuric acid rain. Unmanned Russian spacecraft landed on Venus, but survived only a few hours. Venus is the right size and distance from the Sun for life, yet its atmosphere is poisonous, and its surface is too hot for life.
Mercury is too close to the Sun's heat and high-energy radiation to be a habitable planet.
Our solar system belongs to the Milky Way galaxy, with hundreds of billions of stars and their families of planets. The Sun lies in a safe region between two spiral arms, far from the galaxy's center. Here, stars are far apart and rarely pass close enough to dislodge comets or disrupt planet formation. We live in a place of long-term calm within a galaxy that has a violent core and very active spiral arms.
The Milky Way is just one of hundreds of billions of galaxies strewn across the universe, in groups, clusters, and superclusters, almost all rushing away from one another. To understand the timeline of the universe, and to discover when and where life might appear, we need to follow the motions of these galaxies backward in time, to a point when all matter and energy were in one place at one time. Suddenly, the expansion began in a burst of gas called the Big Bang, creating our time and space. As the universe rapidly expanded and cooled, there was a critical time when the soup of elementary particles could combine into the matter we recognize today, mostly hydrogen and a little helium, in stable atoms made of protons, neutrons, and electrons.
Over hundreds of millions of years, these vast clouds of gas gradually began to fall in on themselves, condensing under their own gravity and producing enough heat and pressure in their cores to become
The Milky
stars.
Way. The Milky Way spiral has lanes of young, hot blue stars, mixed with clouds of gas and dust, regions with an abundance of heavier elements, but perhaps too young for life to have had time to develop or intelligence to appear. In the Milky Way galaxy, we can watch stars at birth and death, showing the past and future of our solar system. We can also discover when stars create the chemical building blocks of life. Into the nebula, we encounter a spinning disk of gas and dust, a protostar. Such protostars not only house the slowly warming balls of gas that will someday ignite into new stars, but are themselves surrounded by clouds of material that may one day become orbiting planets.
A star produces energy by fusing its own hydrogen into helium and other heavier elements. When the hydrogen runs out, the star begins to collapse and die. One such star, Eta Carina, is in its death throes and may destroy itself in the most violent of stellar deaths. A brilliant supernova layers collapse onto the core, rebounding in a shock wave that literally tears the star apart. While the bulk of the star is blown outward, the core itself implodes into a super dense sphere of neutrons called a pulsar. This rapidly spinning core concentrates energy into beams that flash by us like a lighthouse beacon, a signal created naturally, but like one we might expect from an advanced civilization.
not all stars die so violently. When less massive stars like our sun run low on hydrogen, they shed their outer layers into disks or lobes of expanding gas. A few hundred planets have been found, but most are giant worlds as large or larger than Jupiter. It is much more difficult to identify the gravity tug of a smaller Earth-like planet. We assume that where gas giants form, smaller rocky worlds may also exist.
With radio telescopes, we mount a more sophisticated search, looking for radio signals not made naturally, signals indicating the presence of intelligent life beyond Earth. Since the 1960s, we have been listening, and the search for extraterrestrial intelligence, or SETI, continues. Searching nearby likely stars in specific radio wavelengths has yielded much data, but no unequivocal evidence of extraterrestrial intelligence. Yet the sky is large, and the search has just begun.
We suspect that there may be millions of stars at the right age, composition, and location in the galaxy to have planets where intelligent life has emerged. We wonder why we haven't detected a signal from these more advanced aliens. Perhaps we need more sensitive equipment, or perhaps we're not listening at the correct wavelengths. Perhaps Earth is more rare than we thought, and intelligence does not occur often on planets, even on life-bearing worlds. Perhaps intelligence is common, but civilizations do not survive long enough to be detected at our unique time and place. Or perhaps intelligence develops but turns inward, deciding to stay at home rather than exploring the cosmos. Based on our own brief history, any one of these theories could be correct. Regardless, we are certain of one truth. Our search for companionship in the cosmos will tell us much more about ourselves and our own place in the universe.
As we learned from the Planetarium, to your left is Jupiter. And to your right is Venus.